So let's look at an example. So case 1, 2 angles and one side are given. All right, so as soon as you're given 2 angles, you immediately find the third angle. We all know that all 3 angles of a triangle must sum up to be 180 degrees. So 180 minus 32 minus 81.8, 66.2 degrees. We got it. We have all 3 angles. Notice I haven't even made a drawing yet. Come back here. Okay, next. Angle A, side A. These are the information that are opposites of each other. This is what's important to locate, because this is going to be the one ratio that's going to be complete. Now, why is that important? That's the ratio you put in the middle. Remember, I told you it does not matter what order these ratios come in. So all the information given for one ratio is always going to go in the middle. And then you fill in the other information. So 42.9 goes in the numerator for A in the middle. Sine of 32 degrees goes in the middle. And then we fill in the outsides. Okay, here's side B, angle B. Angle B was 66.2 degrees. Here's side C, we don't know what it is. The sine of 81.8, that's the angle C value right there. We now have our proportion filled in. And the beauty of this is you do not have to draw a triangle at all. As long as you're given 2 angles, you can automatically find the third, and you can find all the sine values in the denominator, or if you want to put in the numerator, in the numerator. I have no preference. Okay, now let's solve the proportion on the left. All right, so we're going to say, let's solve for B. Well, to solve for B, you cross multiply. And this is the one and only time I'm going to cross multiply. Sine of 32 degrees times B. Boom, left side. 42.9 times sine of 66.2 degrees. Boom, right side. If I want to solve for B, we divide over the sine of 32 degrees. But here's the kicker. We don't want to enter this as a fraction. It takes a little bit more time. We want to become efficient. So here's my calculator entry. We want to use the division symbol instead. So 42.9 times sine of 66.2 degrees divided by the sine of 32 degrees. So from your proportion, how do I create this statement so I don't have to do my cross multiplying rule? Every proportion does this when you solve for a missing variable. Cross multiply the 2 values that are given, divide by the third. These 2 get multiplied together. You eventually multiply by this third value being cross multiplied to the B. So let's just dump down to here right away once you have your proportion. Here's your work. You create the proportion. All right, create the triple proportion. Boom, create your calculator entry for the left side. Go to the calculator. We enter it in. We get 74.07 blah, 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 blah. All right, they gave me a side value of 42.9 to 1 decimal place. Okay, round to 1 decimal place, 7 rounds to 0 up to a 1. B is done. Now we go to the right side of the proportion. Dun, da, da, da. Now you solve for C. Now you're going to see the method to my madness, so why I do this and how efficient it becomes. Build your calculator entry. Cross multiply the 2 you can. Divide by the third. Cross multiply the 2 values that are given. Divide by the third. There it is. There's my calculator entry. There's my answer. Now, talk about efficiency, folks. Holy cow. Look at your calculator entry. Look at the previous one. I didn't type this all in again. All I did is I copied this entry right here. You can hit the up arrow. takes you to this number, up arrow again, takes you to this statement as long as it's highlighted. Hit enter, hit paste it in, and change 66.2 to 81.8. Second, if you have an older calculator that doesn't do the cut and paste feature, you just hit second enter once, and it gives you the previous statement. The more you hit second enter, it goes up to the previous statements in your calculator screen. And I believe you can go back to as much as, I think, 30 entries. So very efficient by setting it up this way. Always using this original information right here. Your calculator entries are going to be very short, clean, easy to get to. So round to 1 decimal place, 80.1 centimeters. Again, always use given information. So I would not want to set this up as A over sine of A, B over sine of B, C over sine of C in alphabetical order, because once you solve for B, that's a rounded value, and I don't want to put it back into my proportion to solve for C, because then that's going to affect my rounding error. All right, always use information that's given. So this angle is 66.2. I'm going to call that given information. 180 minus given information gives me more given information. All these angles are good. The sides are going to be rounded, so always use the given side in your proportions. Oh, now this rule right here, I call this the Goldilocks rule. Notice what it says. The smallest angle of a triangle will always be opposite the smallest side. The largest angle across from the largest side. And of course, the medium side is going to be opposite the medium size angle. So if I go back, here it is. Okay, angle A, 32 degrees. That's the smallest. That's my smallest side. So when I start this, I know that B and C have to be bigger values. So once I solve for C, which has the biggest angle, 81.8, C better be the biggest or longest side. Yep, 80.1 is bigger than 70.4, bigger than 42.9. So you can kind of see why I call this the Goldilocks rule. One side's too big, one side's too small, one's right in the middle, just right. Okay? All right, next example. Applying the law of sines to an application problem. A ship is sailing due north. At a certain point, the bearing of a lighthouse is 7.6 kilometers away in a north by 38.4 degrees east. Later, the captain notices that the bearing of the lighthouse has a bearing of south 33.4 degrees east. They're both to the east, so the lighthouse is going to be to the right of the ship. So when I draw my lighthouse and I draw my north line, I want the lighthouse to be east of my north line. So first bearing, north 38.4 degrees, and it was a length of 7.8 kilometers. The ship continued sailing north, and then they took another observation. Let's say it was right here at this red dot. That's the south line, 33.4 degrees to the east. Here's my triangle. How far did the ship travel between the two observations? That's the distance between these two observation points. So I have two angles. Find the third angle. 180 minus 38.4 minus 33.4, 108.2. And again, here's my distance we're trying to find. So I have all angles of a triangle. I have at least one side given. It's time to use your law of sines. Well, we don't know this distance of the second observation, but we don't need it because we're only asked to solve for D. Okay, D over the sine of 108.2 degrees is equal to 7.6 over the sine of 33.4. All right, calculator entry, use your cross product rule, cross multiplication rule for your proportions to build your calculator entry. D equals, cross multiply the two you can, 7.6 times the sine of 108.2 degrees divided by the third value, sine of 33.4 degrees. We go to the calculator, we enter it in, we have our answer, 13.11522269. Okay, rounded to one decimal place, approximately 13.1 kilometers. Next example. Two ranger stations are on an east-west line 110 miles apart. So here we are, east-west line, 110 miles apart. Point A is going to be this fire station. Point B will be this fire station. It says a forest fire is located on a bearing north 42 degrees east from the western station at A, north 42 degrees east. And the second at point B has a bearing of north 15 degrees to the east from point B. To the nearest mile, how far is the fire from the western station? So that's from point A to see our fire. That we'll call side B because it's opposite of angle B. Well, if we're using law of sines, all angles must be identified. That's what we have to find. So let's see. Let's start over here with A. North to east, that's 90 degrees on my compass. So 90 minus 42, 48 degrees. Angle B, you have the northwest line, that's 90 degrees, plus another 15 degrees, that's 105 degrees. Now that you have the two angles, you can find the third, 180 minus the 105 degrees minus the 48 degrees equals 27 degrees. Once you have all three angles and any given side, it's time for the law of sines. So we're not asked to find this distance, just B. So B over the sine of 105 degrees is equal to 110 over the sine of 27 degrees. There's my law of sine proportions. But we're just doing one proportion here. Again, once you get the proportion built up, it's time for your cross multiplication rule. B will be equal to, multiply the two values you can, divide by the third. 110 times the sine of 105 degrees divided by the sine of 27 degrees. Calculator entry, 234.0397893, rounded to the nearest mile, 234 miles. Okay, next stop.